Well, thanks for having me here. My name is Rafael. I'm co-founder at Cellpax, and today I would like to talk about metal to service 100% automation with CloudStack and Ansible. I actually think it's important first to put some kind of context, because I don't believe Cellpax, we are the typical CloudStack user. We are actually fairly small company. We like to see ourselves as a tiny global venture. We run an IoT service that you can see below. We basically measure how people feel at work. And we have some 700 installations done in 65 countries, thousands of IoT devices, but we are very small. We are in the 1 to 10 people bracket. Or typical infrastructure to run all of these is around 10 hosts, tens of VMs, 50, 60, 70, around there, hundreds of containers, not thousands, but hundreds. And we pretty much run everything from our private cloud. That could mean our service, but also our support portal, websites, and even our own IT, like sharing drives or synchronizing files, etc. And something very important is that we have 0 cloud engineers. So this is normally an activity that is side project of engineering or product, or own product. So that's this presentation needs to be seen in this context of a small company. Full automation. Why? That's why could a small company pursue having full automation of its private cloud? This is in fact an activity that we started around 2015. So it's been running for a long time, but why would we want to achieve that? The first reason, and I would say that is quite important, has to do with our values and purpose as a venture. We kind of believe in digital autonomy and independence. It's people is starting to think as public clouds are some kind of decentralized infrastructure, but in fact, it is not. A handful of huge companies are gathering a lot of power. And the way we understand public cloud software is like a software-defined infrastructure pattern. You can see that there is a growing phenomenon of the platforming. At the beginning, it was this, for example, social networks. You see people being kicked out. It was worrying to see like elected ministers being kicked out. And now we can see that also companies, startups are being kicked out from public clouds. And all of this with no due process or whatever. So we see as a responsibility. If we grow a venture, we also have to grow the capability to handle our infrastructure. And when there are products like Apache CloudStack, it's actually feasible. It can be done. The second part is economics. Every time we look into this, running our own cloud, private cloud, it's like order of magnitude better in terms of value for money. It's better experience, it's better everything. On the other hand, you need to build the competence. You need to have the competence, but economically, it's way better. And also, it's fun. We like this. We like what we do. We are tech enthusiasts. We just like it. It's a nice part of our work. So that's why we pursue this. And when we talk 100% automation, what does it actually mean in terms of goals for us? Basically, if you get a new piece of metal, you just run some commands, and there you go. Your services are running there. That could be one of the goals. The other goal is if something starts not working well, or you suspect that there is vulnerability being exploited or something, you can just redeploy. You redeploy. You just perhaps save the data for later analysis, but you can just redeploy that piece of infrastructure. You don't have to do anything else. On the other hand, we see this as enablement. How else could we be able to ever run a private cloud if we don't have a high degree of automation? So that's kind of why we run our own cloud and seek the 100% automation. Then the question is, after these years, how did it go? How did it go? How was the road to building that capability? Well, I have to say that it didn't go very well at the beginning. Here you can see your marketing colleagues basically declaring that our whole data center is down. This is what happens when you rely on automation infrastructure and you find out in the heat that it doesn't work, that is not working, and now you have to figure out what is going on while everything is down. We struggled, I would say, for the first years in getting this right, and we basically had underestimated the complexity of what it takes. It's a complex software project. If you think about it, it's a very long-lived project. I mean, your infrastructure is going to be alive as the same time as, for the whole lifespan of your venture. There are many loose dependencies. You depend on the OS, on the cloud software, on automation, collection, plugins. Everything is being developed at very high pace. And, you don't get to decide when the OS is updated. Of course, it is updated constantly. Same goes for hot fixes or any of these pieces of software. So it's very complex. If you compare to other software projects where you can pick your dependencies, freeze your dependencies, it's actually a very complex project. Then, in the case of a small venture like ours, there has never been a clear project owner. So these things happen, and who's the owner? Who's going to deal with it? Do they have the knowledge, etc.? So at the beginning, we thought getting full automation was kind of a complex puzzle, but then we realized that it's more like clockwork. It's a lot of pieces, they are all moving. So for years, this initiative had, I could say, poor quality, or the project did not converge. I mean, you fix something, something else breaks, you fix the other thing, and so forth. So eventually, I would say about a year ago, we sat and decided to rebuild from the scratch and analyze everything that had gone wrong. Why did it go wrong? And trying to get it right from the scratch. On the process, we had some kind of lesson learned. That is perhaps what I would like to share with you today. The first thing is you need to build on solid dependencies, best in class. I mean, CloudStack, it's a fantastic piece of software. It's API first. It's very well tested. It has an amazing community behind. You can ask, you get replies. You can push requests for changes, they get analyzed and they get included. People help. And then it's the CloudStack Ansible modules. They are built on top of this, and the code is easy to understand, even if you are not a Python guru. It's well tested. You can come in, contribute. I mean, when we are talking 100% automation, you always find bits and pieces missing. So this is key to have this possibility. And then is Docker, which we found it very, very key for this kind of project. To give you an idea, when we started back in 2015, these three technologies were different, and we have replaced them all. And the cloud software we replaced twice in order to get this right. So picking the right software to build on top is key, and these are winners, definitely. Then it's layered automation. I mean, when you're going to do 100% automation, you're going to be dealing with bare bone servers, then the OS, then network, then cloud. On top of that comes networks, virtual networks. It's important that this huge stack is separated in layers. Those layers are very well defined, and they have clear dependencies between them, clear interfaces, and minimal as possible. Obviously, you have to avoid cyclic dependencies between them. I mean, what could I say as an example? It's more in this context of small ventures. Say you run a virtual DNS server, and somehow that DNS server ends up being set up in the metal. So obviously, when something goes wrong, the metal is not going to work because the virtual servers are not up yet, and you end up with a chicken and egg problem. And in the context of long-lived project, people coming and go, these things happen. So good layers of automation, good demarcation, so you know at which level you're working. This is key for success in this kind of project. Then you're writing automation software, you're writing software, and you have to treat it like any software product. So meaning you have to deliver something. In this case, you deliver an automation toolkit, but that has to be an immutable deliverable, just like delivering any other piece of software. You need to know what you have out of each release, and that's it's key. And of course, it needs to be continuously delivered. That means in the case of this kind of infrastructure, every time there is a change, and every night you need to build a new cloud, install from the scratch, and automate it and see that everything is working. That there is not change that has introduced regression and broke something at other level. It's also very interesting to do matrix testing. We know that there is a new OS coming. We know that there is a new cloud release coming. So we can start testing now and know that we are going to be able to run on that and automate with confidence. Well, eventually we did address all these things, and we came out with something that works. And how does our automation looks like today? So we have 5 levels of automation layers. The first one we call core, which is where we deliver like bare bone servers. It's like depending on the providers that we use, this basically gives you a running server and secure shell key and the inventory so that you know which metal you have. The next layer, which is the metal, is the one that sets up the OS, networking, firewall, and CloudStack. But it stops at the point in which you get an administration token. That's everything that it does. Then you go to the next automation layer, that is the provisioning. And here is where all the CloudStack objects are creating settings, offerings, zone, pods, clusters, network, public IPs, hosts, templates, all the accounts ready to be used. And the deliverables of these layers are exactly the accounts with their tokens to be used. The next layer is project, where we use basically virtual private clouds with their layers, permissions, network permissions, and instances. And the last one is the services, and this runs basically from the inventory and the project tokens, and that's where the services get spawned. So this way we have 5 well-defined layers of automation. If you're working at core, it's very different to working at project. Everybody knows that. The interfaces are minimal, as minimal as possible, and there is really no way of getting lost here. Then we build our infrastructure for testing cloud, and on every commit, every night, a new cloud is deployed, tested. We have been running this late phase for less than a year. We have already installed more than 1,000 clouds, about 30% of their work. Which is obvious. It's a lot of things happening, a lot of things changing. So, but then we can basically pick and deliver a deliverable that it gets packed as a Docker image, and then we know that we can basically automate with confidence. So in the end, we actually kind of got it right, and we feel we can now run on top of the continuous delivery. We run a number of clouds and environments for production, for testing more new things or trialing new features. And when we experience that services or degrade or something goes wrong on any virtual machine or host, we are confidently redeploying them, and it works with a tremendously high level of success. We really automate with confidence here. So I would like to leave some takeaways of this work we have done, and that could be with regards to metal to service automation. The first thing is that it is feasible. It is very possible to do end-to-end 100% automatic, but you need to take care of a few things. The first is that you need solid core dependencies to build on top. And here is CloudStack and Ansible are total winners, I think. They are perfect for the job. And then you need to deploy a good practice, like with any other software product. Doesn't matter that you're delivering a cloud automation package. Well, it needs to be tested, it needs to be packaged, it needs to be just like any other software. And then you achieve automation with confidence. The other thought is that I believe this is basically enablement out with our size if it wasn't because we have this level of automation. You cannot run a cloud that eventually starts breaking apart or the software start getting old. This is a continuous thing. We think it's totally impossible to run this thing unless you automate for a company of our size. It's also has an economic incentive, and it's fun. I think there are thousands of other small ventures that could benefit from something like this. So because of that, we have decided to basically open source this work. We are putting this together as a open source method to service automation toolkit. See if we can build a community of other companies, small companies like us that can pursue the same thing, maybe share code experiences and take the responsibility together to get this kind of thing going. And that's pretty much all on my side.